Okay, so I was speaking while nakamute ako. Thank you, Sir Bobby, for letting me know. Okay, so welcome back, everyone, to the seventh, oh yeah, to the QNLP lecture series on your tapos. Today is the seventh session of this lecture series. And I hope you guys are really excited now and because there's something new to learn here. So I'm your host for today. I'm Sean from Dev 8. I also hosted in some of the past sessions. Today I'm taking over again. So just here's a few session norms to take note. One, immerse yourself in this experience and make sure that you are having meaningful conversations with each other. And if you have any questions, even if you think they're stupid or dumb, just still ask them. And of course, lastly, just respect everyone. No. Now, before we proceed, we'd like to know how you guys are feeling. So if you last week was a roller coaster, please do type in one in the chat. If you don't know anymore, yeah, there's type two. And if you think this you're glad that it's already a weekend, type in three. You know, I'm seeing a lot of twos. Okay, John, that's like a roller coaster indeed. Okay, that's a lot of twos. Okay, so it seems like everyone's tired. I mean, not everyone. A lot of us are tired right now. Must have been a really busy week, especially for the students. I think some of the midterms. All right, cool, cool. Ones, twos, threes. Right. So just to take note, so here's a quick timeline of our program. So today, November 9, we'll be talking about uh, natural language processing. But by next week, we'll be starting to talk more about quantum natural language processing. And for today's session, we're gonna talk about an introduction to natural language processing. And our speaker for today is someone as a science research specialist from UST ASTI. I personally know him, and he's actually a really fun guy to be with. I'm glad to introduce to you Mr. Angel John Adoptante. Au,
Hi,
are you
Sean.
there?
Yeah. Can-
All right.
Am I being
Okay,
heard?
so yeah, you can be heard. All right. So I'll let you take over the floor. And
Yeah. Thank you, Sean. Good afternoon, everyone. Once again, oops, I'm John Adaptante. So I'm from the USD ASCII, technical project co-lead of the Ethan project here in ASCII. So today I'll be basically giving you a somewhat a crash course. Sorry. Yes. So I'll be giving you a crash course on the basics of uh, natural language processing. So um, maybe just a little um, um, expectation, expectations on expectation setting. Uh, this session is not aimed to give you uh, deep knowledge on NLP, but it's more of a bridge or an introduction on the basics of what you need to know for NLP, and maybe perhaps a start to your journey in the uh, NLP path, and then this will serve as a bridge for the next lecture for next week, which will tackle quantum natural language processing. Basically, our uh, agenda for today would be, oh, sorry, yeah, an introduction to natural language processing, what NLP is all about, um, the NLP pipeline, and the some uh, text processing. Uh, there's a chat. Yeah. some pre-processing techniques that we use, some terms that we use in the NLP world, how we evaluate our models or our pipelines, then maybe some machine learning best practices for NLP if we have that. So yeah, um, guys, if you're ready, kindly type in the letter G in the chat. You're ready for this session. Okay, let's go. So again, expectation setting lang. This would be somewhat of a hybrid setup. So medyo formal, and then there are some basic computations lang. Pero nothing, you won't be computing anything. So basic formulas and then ano ba, uh, some memes, yeah, to lighten up our. So let's start. So just in case you have your phones with you. So if you're using um, Android, you can say, okay, Google, Lumos Maxima. And then for iOS users, you can actually say Siri, Lumos Maxima. So what this would do is actually turn on your, uh, this would actually turn on the torch on your phones. So um, this has been for a an available feature for a while now. So I just wanted to highlight this example just because it's a very great introduction or example to NLP. So imagine just saying your words and um, uh, your phones or your system recognizes your voice or what you are actually saying, what you want to do, and then it is linked into a command that, in this case, opens the torch, yeah, the torch in your phones. Okay, so this is one of the many applications of natural language processing, or what we call NLP. So basically, NLP, according to the article in Coursera in 2023. Okay? So NLP is or natural language processing is a subset of artificial intelligence. So basically, we have AI as the general topic, and then inside is a subset known as natural language processing. Computer science and linguistics. So it's a subset of all three. Basically, an intersection of our AI, comsci, and then linguistics, which is focused on making communication such as speech and text. So take note of that. Speech and text. So basically language, comprehensible to computers. Uh, just just in case you're just wanted to highlight that inherently computers cannot actually understand our what our languages, spoken and written languages. So what NLP does is it's a field of AI that bridges that gap. So uh, we're doing processes or doing experiments or applications that in a way makes computers understand what we're actually saying and the context behind what we are actually saying. So the goal of NLP is to make computers useful for tasks that are in human language. Take note, it's make computers useful. It's not aimed to replace humans. Okay, take note of that. We want to create computers that are useful to humans in tasks that require human language. So human-computer interaction, human-human communication, or simply doing useful processing of text or speech recognition, things like that. Also to keep the loss of meaning at a minimum to maximize communication. Okay, it's not enough that the computer would able to process our text or our speech. It's also important, equally important that it retains context of what we are saying. Okay, mm, that is because the context is very important because it holds the meaning of what we really want to say or what we want to communicate from one person to another or one person to a machine. Okay, So we'll just do a quick history lesson. So uh, divided into three parts. So we have the dawn of it from the 1950s to the 1970s. So NLP is not actually a technology. It's been around for quite some time. So ever since the 1950s, and then the next, the what we call the statistical revolution in the 1980s to the 1990s, and then the current era, the 2000s to the present, which is what we call the learning era. Okay, yeah. Start with way back in the 1950s. The dream of effortless communication across languages fueled the birth of NLP. So during those times, scientists or researchers thought, what if we have machines that could understand, or what if our machines could understand our languages, could and retain its context? What if it could be used for task requiring human languages, right? So machine translation or the translation of one of the machine from one language, translating one language to another using machines is a driving force. Rule-based systems emerged as the initial approach. So just like in programming, it started off with rule-based systems. So these rule-based systems function like complex translation dictionaries. Okay. Basically, linguists meticulously crafted a massive set of rules. So there's a lot of rules that capture the grammatical structure or syntax and vocabulary of specific languages. So for every language that was uh, catered, uh, linguists created this massive set of rules. So there are a lot of rules. So basically, it's like if else on steroids. Okay. Now, so imagine the rules as a think of it. It's like a recipe. Okay? So first, the sentence was uh, broken down, or yeah, the system would first analyze the source language sentence, and then it breaks down its parts of speech. So where are the nouns, where are the verbs, the adjectives, things like that. Then we do matching rules. Each word or phrase would be matched against the rule based on rule base to find its equivalent in the target language. So basically, we extract all the parts of speech, and then each word or phrase would be matched to an existing rule crafted by the linguists. And then the last would be rearrangement. The system would use the rules to rearrange the translated words and phrases to form grammatically correct sentence. So, in the dawn of NLP, I think machine translation was the first task, or basically translation of languages was the first task, or the driving force for NLP. Now, during that time, it was already impressive. In that During that time, however, uh, th- uh, there were a lot of limitations still. So inflexibility. So since there are, uh, like I've said, it was based on a lot of rules, and every language has its own rule. However, languages are full of nuances and exceptions. So it could, rule based could only do so much. So what about it could only cater to straightforward sentences or phrases. So how about the idioms, slangs, variations? Imagine if let's say in 2024, there are a lot of variations in Tagalog or English. Where we even have what we call the Gen Z slang. So how would you create those massive amount of rules, and then in just a year or two, the languages evolve very fast. So you need to come up with a new set of rules. So this never-ending chain is why one of the dilemma back in the day. Flexibility. Again, scalability issues, creating and maintaining a vast rule base. So for every say uh, new uh, what do you call this? A new situation, you need to come up with a new rule, making sure that it doesn't contradict with the existing rules. So there's the issue of scalability. Then of course limited scope. So these systems primarily focus on syntax and vocabulary. So it often fails in capturing the deeper meaning and context. It could capture some context, perhaps, but not in a very deep level. So in so the results or the translations that we had back in the day were they sounded grammatically correct, but sometimes it doesn't make sense. Okay. Then comes in the 1980s to the 1990s what we call the statistical revolution. So what from rule-based systems we had this paradigm shift that we transferred into machine learning algorithms, which are basically statistics on steroids. Uh, then, of course, during this time, scientists and researchers started to collect or amass a large amount of data that could be used uh, for these statistical models. So a collection of large collections of text data are known as corpus or corpora in uh, plural forms. So these were beginning to be available to all researchers. Then, since the introduction of machine learning during those times, systems were able to learn patterns from text. So unlike before that you had to set all of the rules for every decision or for every status, things like that. Uh, the system itself was actually quote unquote learning the patterns or checking the for patterns, checking for uh, what happens if this happens if this is present, things like that. So yeah, and then this was only taken up a notch in the early 2000s up until the present, where we call the deep learning era. In the 2000s, well, um, started what we call the deep learning revolution. So artificial neural networks, uh, which mimic the way our brains think or our brains function, were introduced and then became the foundation of deep learning advancements in natural language processing. Then lately, there have been advanced architectures like what we call recurrent neural networks and then the transformers. Uh, these architectures are the foundations of the uh, large language models and the applications that we're using today. Uh, Most notably, if you're all, I'm sure you're all familiar, OpenAI's GPT-4 or ChatGPT. So those are based on transformer architecture. And actually, in researchers are foreseeing that in the next notch from large language models would be what we call multimodal. But that's a topic for a different day. So now that we have this basic understanding on uh, what NLP is and a brief history of NLP, we uh, will be going or proceeding into what are what we call the downstream NLP tasks or what tasks fall under what on NLP, what are the tasks that are considered to be under the NLP umbrella. So there's a lot actually. So anything that has to do with language or speech falls under NLP. So text classification, information extraction, again, machine translation, parts of speech, tagging, things like that, summarization, text generation, sentiment analysis, semantic parsing. So just to name a few. So we have machine translation. So once again, it was one of the earliest tasks in NLP. So translation using machines to translate from one language to another without any human intervention. So uh, the translation is done by the machine entirely. So no human intervention is used or well yeah used in this task. By far the most popular is Google Translate, or if you have iOS, there's a Translate app which supports 100 languages and serves over 500 million people daily. Okay, so next is speech recognition. So like what the example that we did earlier, Lumos Maxima. So speech to text, ability of the machine or program to identify words spoken aloud and convert them into readable text. Well, in earlier case, it was translated into a command for the system, but yeah, basically it's speech to text, recognizing what the person is saying and converting it into text, readable text. Text summarization. So very self-explanatory. If you have a very long document, so you can compress it into, let's say, a one pager. So basically, you're summarizing the entirety of a very long corpus or corpus without losing the entirety of the context or the meaning of the entire corpus or corpora. Okay. And then what we another one is sentiment analysis. So this means to identify or check the emotion of the text, quote unquote emotion. So what is the text saying? Is this happy? Is the text uh, does, does the text reflect a happy note, a positive note? Is it a negative connotation? Does the text reflect anger or fear or sadness or joy? So is it positive, negative, or is it neutral? So this is the sentiment analysis task. Okay, and then chatbots, if you're familiar, it's a conversational agent that uses NLP to understand and respond to human language inputs. We have Alexa, we have you Google Assistant, Cortana, and then Siri. So these are four of the most famous, well, partly text chatbots, but actually, yeah, if you go to other websites, most of the websites right now employ their very own chatbots when corresponding. Then named entity recognition. So simple words, NER. Oops. NER is process of detecting named entities such as a person or name, location names, company names. So um, from the entirety of the text. Then we have a question answering. So this is kind of like some of the applications that is very popular these days. So you document, try to upload a document, and then you try to ask the chatbot or the agent, hey, in this case, Python is Python dynamically typed? Then yes, Python is dynamically. So that um, well, the system answers based on the existing context of the documents. Okay, this is also what we call the RAG pipeline or the retrieval augmented generation pipeline nowadays. And then something that's very close to our uh, DOST as is heart. So this is what we're doing right now: semantic parsing, process of converting natural language questions or sentences or utterance into a logical form. So something that could be understood by the machine. So it could be natural language to code or natural language to, let's say, Java or Python, things like that. But even now, what we're doing is uh, we are converting natural language questions into SQL statements. So basically, that's a certain section of Ethan that we're doing research. So yeah, so just in case you were wondering where can you get started with NLP, what are the tasks that you can do for experimentations? These are some of the examples. Okay, okay. So um, earlier we said that language is a very complex thing, uh, and that goes for English or uh, say Spanish, for French, for Filipino. So all languages are complex. So imagine creating systems that are that could cater to natural language. So regardless of what language it is, language and NLP by extension is just not that easy. So because to, you know give you an insight on how complex language really is inherently, though not just Filipino language but different languages in the world have this what we call ambiguity, expressivity, sparsity. We have the scale and the variation we'll be discussing. So let's say in ambiguity. So let's say you see or you hear, okay, the word back. What comes into your mind before when you hear the word back? Okay, is it is it well an institution or a place where you deposit and withdraw money? So a financial institution, or is it a river bank or you know, as a part of the river, things like that. Putting you're currently seeing what I'm trying to express right here. So let's say we have a chair, a chair. So are we talking about the chair of a committee, the head of a committee, or a chair which you can sit on? So the words, okay, words are or language can be very ambiguous depending on the regardless of the structure of the or structure of your sentences or the words, it can still hold different meanings. Imagine, let's say, this the sentence I saw bats. So did you saw or yeah, saw use a saw to cut a baseball bat in two? Did you see many bats? Did you see many baseball bats? Or did you see saw cut an animal into two? So the sentence I saw bats, okay, can still be very ambiguous. Um, so as humans, we kind of know, can somehow extrapolate, but imagine machines dealing with this type of ambiguity. Let's check for other examples. Okay, include your children when baking cookies. So, diba? Very, if, is it um, when you look at the sentence, can you um, conclude that you must what do you mean by include your children when baking cookies? Do you bake with them? Okay, you do baking sessions with your children, or do you include your children themselves into the cookie batter, and then bake them as cookies? Still very ambiguous. Local high schools, local high school dropouts cut in half. So again, they're ambiguous sentence. So is the drop? Are we talking cutting the dropout rates in half or literally cutting all the dropouts in half, diba? So this is another ambiguous. Well, of course, this you may find this somewhat funny, things like that. This is actually uh, a very hilarious moment. But imagine the system or our system or our computers inherently do not know what we're trying to say. If maybe this is what we're trying to say. Then boy paralyzed after two more fights back to gain black belt. So was he did his tumor fight back with the boy? Then the boy got paralyzed, or did the boy paralyzed after having a tumor get gain a black? Then another issue is what we call uh, expressivity. Okay, the way we express our thoughts. So we can have earlier we have the same sentence, multiple contexts. Here we have the same context but different ways of saying it. In this case, let's say she gave the book to Tom, or she gave the Tom the book. So how will the system know that these two sentences are saying the same thing? That and that's maybe could could do that since basically it has almost the same words. But let's say we try to change our sentence. Let's say some kids pop by versus a few children visited. So there's different words that are being used right now. So how will the system know that these present the same context when they are very very much different in structure? And then finally, is that window still open? Versus, well, please close the window. And that's just the tip of the iceberg. Again, like I've said, language is constantly evolving, so we have this different slang that we use. So I know, right? Shaking my head. He asked for your last name, so he can add you an FB dollar. So how would the system understand what you're trying to say or the context that you're trying to transfer? Then again, yes, babe, how you look gorgeous. So uh, there's also an existing new language right now we call Gen C slang. I think Gen Alpha. I don't know, not really well versed in that. So yung mga skibidi toy, things like that. So how will the system understand those types of and then of course sparsity. There's a lot of words in well technically one language. So there can be a lot of words, a lot of context. But how about for multiple languages? So there's a lot to take into consideration into language itself. We also have scale. So if, like I said, there are a lot um well applications or the tasks that we have. Let's say POS stacking, machine translation, and there are also a lot of languages existing in the world. And then the counterpart is there are a lot of tasks and a lot of languages. There's also a lot of domains: agriculture, research, healthcare, education for these types of applications. So these are the issues that we um, are trying to consider when developing systems that will understand uh, natural language. Okay. Now, to try, quote unquote, try to understand our languages, we create these what we call NLP pipelines. Okay. Pipelines refer to a series of interconnected steps. Basically, it's a step-by-step process so designed to extract uh, meaningful information. Take note. meaningful information. So we're retaining the context from text. So these pipelines are customized depending on your tasks. So depending on your task, it change badly. But basically, the basic NLP pipeline goes a little something like this. Okay, so we have data collection step. We need our data. You cannot create, you cannot model or system to understand language if it doesn't have any data to work on. Then after creating or collecting our data, we do what we call text cleaning or clean our data. There's a saying in AI which we say garbage in, garbage out. So the quality of your outputs depend on the quality of the data that's used in training. Again, the next step would be pre-processing. So we do some pre-processing techniques just to make sure this is an additional step. Make sure we have a clean data. Then feature engineering, we extract meaningful features from our text and convert it into something that a uh, our system or the computer could understand for processing. Then modeling or training our AI model to process. Then after training our model, uh, we evaluate its performance. If it results to a great performance, we deployed our model and then we just continue to update and monitor. So in this part, we'll be discussing first basic pre-processing techniques. Okay, so why do we need to do pre-processing? Why can't we just go from, let's say, raw text into direct feature engineering, then modeling? So basically, basically, it's to reduce what we call noise or distortion for text. Then, of course, standardize the consistency of every input. Then we also do pre-processing to handle the earlier discussed linguistic variations, and then also to reduce the amount of data, at least the size of data and the efficiency without risking or losing uh, the entire context of our initial data. Okay, so yeah, uh, some pre-processing techniques. So we have this segmentation. So we split uh, long, long sentences into shorter phrases. In this case, we segment using uh, for every comma, we segment things like that. For every period, for every sentence, for every paragraph, for every chapter. So it depends on you. Then next we have tokenizing. It's basically uh, the gist of tokenizing is splitting it into what we call tokens. We'll discuss this a little bit more. And then we stop words removal. So basically we're removing low words, usually around prepositions, and then the was, the in, are, and things like that. We're removing those. Uh, so uh, so we're only focusing on the important words that hold majority of the context. And then we have stemming. So basically we're getting the root word. Then yeah, in this case, let's say skip. We're getting the stem skip. Then plus the addition of or uh, additional particles added. Then then again lemmatization, the original lemma or this word. So am are is we are getting the lemma which is B. Next is next is speech tagging or tagging for each word in the corpus, the data. We're tagging what part of speech it falls under. And then finally, named entity recognition. So we're trying to check if the word is a name of a person, a name of an occasion, name of an or what entity it is. Okay, and this part will be checking out what we call tokenization. So we're going to dive a little bit more into tokenization because this is one of the most important parts or processes in natural language processing, especially in today's applications. So tokenization is a way of separating piece of text into smaller units. So we're separating very long or piece of text into smaller units known as tokens. Um, Tokens can either be words, characters, or what we call subwords that hold meaning or context. So we have this what we call word level tokenization. So let's say in the sentence boys and girls keep it real. We use word level tokenization. We have boys and girls keep it real. So we're separating uh, every word. So you can do this either keeping including what we call the punctuation or also tokenizing the punctuations as well. Then for characters, um, level tokenization, boys and girls keep it real. We just split it into characters. Now, for subwords, rely on the principle that frequently used words should not be split into smaller subwords, but rare words should be decomposed into meaningful subwords. So, use um, famous example would be byte pair encoding. It's mainly used right now in what we call this, state-of-the-art applications or state-of-the-art architectures. So, simplest form of data compression, in which the most common pair of consecutive bytes of data is replaced by with a byte that does not occur within the data. Yes. So so again, once we convert into the entirety of the text or our data into tokens, we need to transform these tokens into something that uh, our system or our computer can understand. And our system inherently can understand numbers or numerical formats. So this is what we're going to do in a step in which we call uh, feature extraction. Okay. Okay. In feature extraction, it involves creating uh, the word is structured numerical representations. So feeds of the text to capture important information about each document and the documents. So we're converting text into a structured numerical representation. So by extracting features from tokenized text, we create representations that highlight useful information. So we're converting that context into numerical representations, making it for models and the system itself to understand what we're trying to say. Okay, so there's basically we can categorize feature extraction methods into two parts or into two types. we have the frequency-based methods. And again, the next is, which is more commonly used today, is what we call word embeddings. So we'll be taking a deeper dive into these types of uh, feature extraction methods. Okay, but before we do, uh, if um, if you're still okay so far, okay, we will have a short reader lang. Okay, type in the chat if you're still okay. If press one, if you're still okay and good to go. Press two if you're still, you know, you need a little bit of a break. Okay, okay pa naman, everyone. Yeah. So okay pa naman. I'll also ask if my audio is still okay. So hello, maybe we can actually before we dive into types, I think we could do a 5 minute break. Just yeah, so medyo mahaba po pala yung next part. Yeah, we could do a 5 minute break. Okay, stretch. Okay,
Thanks.
nice. So again, welcome back everyone. So hope you enjoyed our quick 5 minute break. So previously discussed, we'll be diving into two types of feature features. We have features extracted using frequency-based methods, and the other type is what we call word embeddings. So from the name itself, frequency-based methods involve counting occurrences of words in the text and are really relatively simple but powerful for many tasks. Basically, we extract all the words, okay? Extract all the words and then we just count how many times it occurred in our training text or in our corpus. So that's why we call it frequency-based methods. Um, an example of this is what we call BAO or uh, bag of words. So basically, in bag of words, it represents the text document is it's like a bag of all its words. So we disregard grammar and word order, but we keep track of the word frequency. So we get we extract all the unique words in corpora and throw them into what we call a bag. So that's all our what we call vocabulary. Then we also keep a track on how many times each unique word appears in the entirety of our initial corpora. So basically, you can put it this way that let's say we have a collection or long text, lot of text data. Then we extract all the um, unique word, then dump it into what we call a bag, and then we just count for each unique word how many times did it occur in our text data. Now, um, for so how this works is again we tokenize and create the vocabulary, then with all the unique words, and then again we vectorize that each document is represented as a vector of word counts, where each element in the vector corresponds to. So we're basically creating a vector representation. In this case, if a word does not appear in the document, the count is zero. If it does not appear, if it appears, then you just add or represent by how many times it appeared. So basically, we have this a vector of n number of size n corresponding to the number of unique words or tokens in our bag of words. Then for each index corresponds to same index of the word of the unique word, and then the value corresponds to the frequency of that word in the original document. So in this case, let's say this one, the I love this movie. It's sweet, but it's with satirical humors, blah blah blah. So we can represent this text into a vector that is 6, 5, 4, 3, 2, 2, 1. Well, depending on of course, this depending on this the uh, unique words. So we're going to use this. Then let's say we extract the vocabulary. Say we have in our training vocabulary, we have dog, cat, and fish. So those are the unique words only. So a document like dog and cat would be represented as 110 because dog appears, cat appears both once in dog and cat, while fish does not appear at all. So it doesn't account uh, for no matter where it occurs it's in the text. As long as it occurs in text, we count it. So we disregard all the structure of the sentences. As long as it appears, you add one count. So for of course, this has its advantages. It's very simple. It's very easy to execute. Very straightforward. And in terms of computational resources, it's very inexpensive. You'll just be counting how many times it occurred. Effectiveness for simple tasks. It works well for text classification or word presence or frequency is a useful indicator. Of course, there are its limitations or disadvantages. So again, earlier, what we've said, we disregard the structure of the document entirely. So as long as it occurred in the document, we count. So it doesn't capture word order, syntax, or semantics. So, for example, I love cats and cats love me would have the same representation. Well, given our uh, if we're using dogs, cats, and fish, so it would be 0, 1, 0 for both. So different documents, same representation. High dimensionality. So as you imagine, as the vocabulary size grows, the vector representations become very large, especially with sparse word usage in documents. So the size of the vector representation depends on the size of your vocabulary. And if you have, let's say, 1,000 unique words, your vector representation it contains 1,000 items or 1,000 entries. If it's 1 million, it's 1 million, things like that. So it would uh, have a very very high dimensionality. So another example of what we call frequency-based method is the term frequency infers document frequency. So TF-IDF for short. It builds on bow or bag of words by adding a weighting factor to account for the importance of words in individual documents and across the entire data set. So for this one, we first compute what we call the term frequency or TF. So the frequency of a word within a single document. So for that, we have TF uh, is equal to number of times the word appears in the document. So how frequent it occurs over the total words in the document. So how many total words are there in the entirety of the document? So it's just a ratio of frequency of that word over total number of words in that particular document. So that's term frequency. How frequent does that word occur in your uh, in your document? Then we also compute for what we call the inverse document frequency (IDF). So a measure of how important or well how unique or important a word is across all the documents. Words that appear frequently in many documents like sa or and get a lower grade. So IDF is computed by the logarithm of the total number of documents, how many documents were used in training, divided by the number of documents containing the word. How many documents contain, let's say, the word cat or the. and. So we just take the logarithm of the ratio of the total number of documents over number of documents containing the set word. And then for the final score, the final TF-IDF score for a value of a certain word, just for a certain word, is calculated by multiplying TF and IDF. So basically multiplication. Okay. Um, this is repeated for all the words that. So sorry, this should be TF-IDF. So TF-IDF reduces noise. So by downweighting common words like the, and, is, are, am, TF-IDF highlights more distinctive terms, improving the quality of feature representation. So effective for keyword extraction is used to extract keywords that are unique to certain documents. Again, TF-IDF has its own limitations as well. So it still loses context. So it still doesn't capture the order to word or the semantic relationships within this document. Uh, so context is still not retained, and then less effective when shorter documents. So TF-IDF, it can be very unstable when using very short documents. So we also have this what we call dictionary lookup. So basically somehow related to, but it existed way before we had computers. So basically we map each word to a unique number. This unique number is used as a representation of the corresponding word. Let's say we live in a universe, let's say, where it has a language that only has three words. Okay, I am Guru. So we assign an I to each word in the entire vocabulary. So zero for I, one for am, let's say two for group, things like that. And then basically we just represent the entirety of the text using these I. Then we do one. We also have what we call one-hot counting. We create a vector with field zeros except the one that you want to represent. So let's say we have I am group. Okay. So I is represented by 100, and then we also have this. We also add another token or another entity in our vocabulary, which is unknown. If it's not part of the unlike unlike the dictionary lookup, it's not part of your vocabulary. We just take the unknown. So let's say I would become uh would be represented by 1000, and then the sentence I am Groot would be represented by the vector 1000, 0100, 010010. So this is how we represent for one of the coding. So I am Groot. With this would be combined. So 100. So I am Groot could be also represented as 1110. And then you can also represent I am not Groot by 111, since I am and Groot also exist. And then we also have another tick on, let's say, well, uh, not, which is not part of the vocabulary. Now, those are some of the examples of frequency based. And then for um, in the next type is actually what we've been using for a while now, and the foundation of uh, what we're well translating or converting or retaining the context of our text, which is what we call word embedding. So we have this word to vec glove contextual embedding, such as word. Those are some examples. So we create dense vector representations of words. So basically, we represent them into uh, something that captures the meaning and relationships between words. Basically, it's not just frequency based. We're converting the entirety of the context into a vector representation themselves. So what what it did is it represents using a feature learning model. Each word is represented by a dense vector with a fixed and lower dimension. So we set it into unlike earlier that it depends on the uh, vocabulary. Word embeddings are fixed, so you can set the dimensionality of the word vectors. Let's say you want to represent it in, let's say, only 50 dimensions or 50 items. Let's say 20 dimensions. You can do that. So we're compressing the context of uh, we're compressing each word or the contextual representation of the word into a fixed dimensionality vector. So that's vector with a fixed and lower dimension compared to the size dictionary. Physical property of this distance vector is words with the same meaning will have the similar vector. So um, and unlike 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 uh, the earlier frequency-based approaches, in using word embeddings, you can actually check or retain the context, and by extension, words with the same mean would have similar or more similar vectors, or very close vectors, especially when you map it out in a let's say in this dimension. Let's say we represent it in 3 dimensions. Uh, see, so the vector for man would be closer to the vector representation of the king, and then and farther from the vector representation of a woman. So, however, the vector representation for a woman would be much closer or much more similar to uh, the vector representation of, let's say, a queen. So this is achieved using in 2003, Joshua Benjo published a paper. Uh, idea of word embeddings into context of neural networks. So neural networks were used to generate the numerical contextual representations, which we call word embeddings. Okay. So one of the most well well known samples of vector representations is what we call word to vec. So word to vector. It provides a this was introduced by Thomas Mikolov et al. In 2010. It provides a simple algorithm to produce embeddings from the unlabeled text. So these embeddings have several important properties that a champ report. The most important, uh, the most impressive property is the similarity between words. So unlike before that we're kind of um, generating a dense vector based on the per word of the vocabulary. Here, we're using for each feature. So let's say in the example, let's say you want to create, say 1, 2, 3, 4, 5, 6, 7. So we want to create a vector representation of words in 7 dimensions. Okay, so say and those each entry or each item element in the uh, vector representation corresponds to, let's say, a certain feature. Uh, like for let's say the first one is about living being. So a living being, then is it a feline, part of the feline family? How feline part? Then is it a human? And then the gender. Is it royalty? Is it a verb? And then is it plural form? So let's say for cat, we can represent this to, let's say, again, this is usually normalized. So the closer the number is to 1, okay, the closer it is to be, let's say, a living being. So the farther is it to 1, well, it means that it is far from being a living being. So for cat, 0.6, so it's very much close to 1. So we're assigning. And beaches are usually extracted using automatically extracted using neural networks. Okay, so we represent a cat. Let's say these are the categories that we're using: living being, feline, human, gender, royalty, verb, plural. We can represent the cat into 0.6, 0.91, 0.4, negative 0.7, negative 0.3, and negative 0.2. So that's how we represent. So this is fixed. Okay, we just can set the dimensions, and then automatically the uh, through training and through learning by the neural networks, it extracts the necessary features in the entirety of the document. So kitten, dog, and house. If you can see, um, if you would compute for kitten, it's close to 0. To cat and dog in terms of living being. But in the next element, you see 0.8 is yung value niya for feline. Closer to cat, 0.9, and very, very distant from dog, which is negative 0.1, saying that if the kitten is more feline, more feline features than a dog, which does not have mostly feline features. So you can see na parang this is the power of word to vec, that it has the property na similarity between. So, and the best part of this is since vector siya, okay, it's a vector representation, you can also do um, operations on the vectors of the word. Let's say we have a vector representation for, let's say, a king, okay, and then we subtract the values for the vector representation of a man, and then we replace that and we add the vector representation for a woman. Okay, so the vector representation for king minus the vector representation for a man plus a vector representation for a woman would most probably be equivalent, not equal, equivalent to, uh, but close enough to the vector representation. But we take note that this is not this is not the equal sign. That's because it could also be a princess, it could also be a duchess or things like that. So, well, the closest would be the queen, of course. So I hope you're getting the gist of this. So word to vec, you can do vector operations. So then we have what we call glove. So this is just another type of vector representations introduced in I think 2014. Yeah, 2014 by Pennington et al. So matrix factorization techniques, word context matrix. And then we also have another one, fast text. So it's basically just an augmentation. Uh, this leads, I think this, if I'm not mistaken, yeah, to improve vector representation for morphologically rich language, fast text provides embeddings for character and graphs, representing words as the average of these embeddings. So it's basically an extension of the word-to-vec model. So if you're interested in learning more about fast text, it was published by Bojanowski et al. In the well uh, paper, enriching word vectors with subword information, way back in almost 2017, so around 7 years ago. So we also have what we call contextual embeddings. So these embeddings are a type of word representation. So the earlier discussions of word embeddings, each word is represented by a vector. Okay, so the trouble with that is words with multiple meanings, okay, have the same vector representations. Okay, because it would during training the network averages all the values things like that to create a single representation for that specific word. For contextual embeddings, basically instead of um, generating a representation for just the word, we try to represent the entirety of the context. especially accounting to not just the word itself, but all the surrounding words that could add context to the sentence. So again, like traditional word embeddings, like word to vec and glove, which assign a fixed vector to each word regardless of context. Contextual embeddings take into account the surrounding words and their syntactic and semantic relationships. Okay, so the early word to vec, glove, fast text, they only represent word per word. In contextual embeddings, the representation of the words varies depending on the entirety of the context, depending on what on the its surrounding words and their syntactic and semantic relationships to that specific word. Now, let's do a pop quiz. Okay, this is just take a quick guess. Uh, there's there was this very famous uh, what's the right term? Example of contextual embeddings. Can you guess its name? Hint. It is a character in a famous TV show for children. Okay? Ito yung ano parang early, early pa. Early uh, representations pa na. Uh, yung parang first one. Okay, so it's a character in a popular TV show for kids. Anyone? Type your uh, answers in the chat box. So I'm seeing Sir Elmer. Mukhang meron na siyang uh, sagot. What about the others? Wala lang. Wala na hula. Well, so we have Sir Elmer said Bert, and then Elmo, and then we also have Wally. Wally, okay. Any others? Simba. Simba. Kasi yung yung meme na gamit natin dito is Lion King. Good guess, good guess. And any others? Going once, going twice? Wala na? Okay. The correct answer is, well, one of during that time, the most popular one was, well, Elmo. Si Elmo. Elmo yung name. No, ano. And well, later on, it was followed by, well, architecture naman, or model naman kasi yun eh. So, it was followed by Bert. But in yung mga early days, si Elmo talaga yung para naging famous na parang initial bridge into contextual representations. So it's what we call embeddings from language models, developed by way back in 2018 lang. So that's 6 years ago when I introduced the Elmo sa world. So again, yung problema is yung words with multiple meanings in word to vec at saka past text and angel, they are represented by the same vector representations. However, these words, depending on the context and depending on the surrounding words, can change their parang context or meaning. Or let's say, I can trust you. Trust is, let's say, uh, pag, parang hindi kita kaya pagkatiwalaan or yung tiwala. Trust. Have no trust left in for their friend again. Tiwala. But it also has a trust fund. Trust fund meaning something more unfinancial. And also, yung word yung sa first and second sentences, I can't trust you. Trust meaning it's a verb, it's an action. And then they have no trust. Trust is tiwala again. Uh, but in this context, it's a noun. So dapat there should be a difference in the representation uh, of these words. So in the previous approaches, we have this parang uh, glove word to vec fast text na iisa lang yung representation, parang ina-average na lang all the depende na lang sa kung ano yung gagamitin mo training data. However, in Elmo, these three would hold different, uh, different, tawag dito, different vector representations. Again, depending syempre on the uh, words that's found. And then, basically, ito lang yung way kung paano na-create sa Elmo. Um, Elmo is created again using large language, or not large language models, large language models. So embedding language models which were basically, in this case, galing siya sa mga RNNs, recurrent neural networks, LSTMs. So I won't get into the specifics of that. So uh, how Elmo works, so we did a character level encoding. So into each character in a word into character level embedding using a character convolutional neural network, so CNN. So these embeddings capture information about the words, morphology and spelling. So yun yung ginagawa niya. So character level muna na encode para makita yung morphology at saka yung spelling mismo ng word. Then we do word level encoding. They are fed, yung character level embeddings, they are fed into yung RNNs, basically bidirectional LSTM players. So the forward and backward LSTMs process the text in both directions. So tinitingnan niya yung text that came before the word and the text that came after the word, allowing them to capture the relationships between words within, well, yung entirety of the context. So hindi lang niya tinitingnan yung mga words that occurred before, but also the words that came after. Okay. Then we generate what we call contextual embeddings. The output of the bidirectional LSTMs is a contextualized representation of each word. So yan. So nagkaroon ng na-represent yung word based sa mismong context niya. Including yung entirety. Parang yung entirety ng lahat ng words in that document or in that sentence. These embeddings take into account the entire surrounding context of each word. So allowing for a richer representation. So mas accurate compared sa mga previous approaches, yung mga ganong context. Again, ang sumunod na right now there are a lot of other approaches na. So, pero Elmo was the start. I won't be IB, pero there's also BERT. So basically BERT is an architecture pero nakakapag-create din siya ng, well, yung mas maganda embeddings and then syempre yung transform architecture. So now, so again, yung modeling. So depende na yan sa nagbabago yung type of model niya depende sa kung ano yung downstream tasks. Pero we also have to take into account yung evaluation metrics. So how do we evaluate gaano ba kaganda yung performance ng what ng mga models na ginagawa natin? Because if the goal is to create or develop systems that would help humans. So of course, we're targeting for a very, very high performance. So imagine kung gagamit ka ng system tapos hindi naman na mas maganda na intended to be used to help humans. However, it's not that great in performance wise. So what's the point of using those types of systems? Diba? So I think we'll be discussing at least some of the more famous types of evaluation metrics. We have the accuracy, yung precision, yung recall, and then F1 score. But take note, these are the basics. So for each type of task that you do, there's a separate set of evaluation metrics. But overall, these are the parang basics na that we usually use. So depending on use case, again, you can add additional evaluation metrics that is catered or specific to those types of use cases. Basically, accuracy, it's a ratio of correct predictions to the total number of predictions. So, how many true positives or positive or positives that should be positive, or yeah, the true positives, and then of course how many did the model how many correct answers did the model predict, or correct labels did the model predict correctly, then how many wrong or basically negatives did it also uh, uh, predict correctly. So true positives and true negatives all over the total number of predictions, how many predictions did this for accuracy hold. Then we also have precision. So ito naman, proportion of the true positives among all the positive predictions. So basic positives. So true positives divided by the true positives all over plus syempre yung mga false positives na tinatawag natin. So uh, prediction that should have been negatives but tagged as positive by the model sort of prediction. For recall, the proportion naman, so balik tayo. Precision, true positives over true positive plus false negatives. In this case, ang recall naman, proportion of the true positives among all actual positives. So, all actual positives would be true positives all over true positives plus false negatives. So, kanina, false positives, dito, false negatives naman sa recall. And then, this is what we call the F1 score, basically the harmonic mean of precision and recall. So, two times precision times recall all over precision plus recall. Ganun lang kinocompute yung. So, ito yung four basic na evaluation metrics that we use in NLP and in AI in general. However, for each downstream task that you do, there are certain sets of evaluation metrics that should be added to better gauge your performance. Actually, this is uh, where my lecture would end. So, kung napansin nyo, this wasn't really meant parang to give you a very, very deep dive setup. So this is just a tip of the iceberg. So this is the starting point. So if you're, of course, very interested, or again, on a side note, we could do also another lecture naman, no, parang a deeper dive into the architectures, things like that. Pero I think this would be sufficient enough into at least getting a gist of what NLP really is, and in turn transition into the next lecture for next week be quantum NLP, no? Which should be a very, very interesting topic as well. And then, yun nga, sabi ko, if everyone would be more interested into a deeper dive into NLP, you could just contact our host. Maybe we could set up another session that's dedicated for NLP mismo. So I guess that would be the end of my presentation. I deliberately made it a very quote unquote short presentation, but there's more time for us for discussions, for question and answer, things like that. So yeah, thank you very much for listening. Uh, meron tayong napulot at least kahit konti man lang during this session. Thank you very much for listening.
Right. So thank you, Al, for that wonderful lecture. So everyone, if you have questions, please feel free to ask us. You can use the QA. Yeah, you can use the QA feature of, Q&A feature of Zoom. But if you prefer, you may also ask in the chat. So Al here is ready to take your questions, and we'd love to know what you guys want to learn more, what to ask. Feel free. There are no stupid questions. No, to start this one out, I do have a question now. Diba, accuracy,
Mm-hmm.
precision, F1 score, and recall. We use that kasi back then.
Mhm.
Ano pa ang mga ano, like ano pa yung other metrics na typically ginagamit for NLP?
Ah, yeah, actually, again, depende siya sa use case. Pero
Mm.
kapag halimbawa you're developing a language model mismo, you could actually add, there's this metric which we call perplexity.
Mhm.
So perplexity naman, this indicates how the model responds to, let's say, uh, text that wasn't yung parang unseen text. So it measures how the model basically responds to quote unquote chaos. So yun. So the lower the perplexity, so
Mhm.
the better it means that mas maganda yung response ng model to those unseen data. So that's one. Um, in 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 RAG, we have this, syempre, sa LLMs, we have yung parang, uh, or in translation, meron yung mga blue score. So how accurate was the prediction based on, let's say, ano yung, we have
Mhm.
this, yung predicted and then yung actual dapat na translation. So, kino-compute, check natin how accurate using what we call a blue score. So, based on n-grams naman yun. So, how many sequences of text in the predicted text is
Mhm.
parang occurs in the actual. So, kino-compare lang siya. So, say, sequence of 2 words, 3 words, 4 words, how many. So, there's a lot of, and uh, usually yun nga, pinaka pa rin, crucial pa rin syempre yung accuracy ng model, then F1 score. So,
So when you train, just to add, may experience kasi with AI is relegated to more on CNNs, machine learning
mhm.
talaga. So I haven't really delved sa NLP. When you do you also split your data set pa? Like what, like 70/30, ano, like something like 60/30/10? Yeah, something like that. Do you do the same?
In training, yes, usually, well, depende syempre kung gaano kalaki yung kung gaano karami yung data na meron ka. Pero
Mhm.
usually, uh, kapag konti lang yung data, usually 80-10-10 kasi kailangan natin mas
Oh.
maraming data.
Mhm.
Pero typically, ang ini-employ talaga namin is 70-20-10. So 70% of your data is used in training, 20% in validation, and then 10 use testing. So
Mhm.
that's typically how we do evaluation. Typically how I do evaluation on my end. So
Oh,
ina-adjust ko na lang depende sa amount of data that we have.
okay, okay, that's cool. Okay, now we actually have a few questions from anonymous participants. So let's do with the first one. So he's saying, what are your recommended resources for learning CNNs, RNNs, and architectures like BERT?
Um, Ako, I'm a big fan of watching lectures on YouTube. So, um, may online yung mga yung Stanford classes.
Mm.
So, yun yung talagang pinapanood parang every time na may mag-a-ask, what's the entry point or how can we parang start our journey. So, we give them yung parang lectures ng Stanford because those are very, very comprehensive. So usually, yeah, there's a lot. And then yung mga books na O'Reilly,
Mm.
like I forgot yung specific, pero may mga books kasi si O'Reilly na yun na for machine learning, for specifically for natural language processing, things like that. Um, yeah, and then siguro the sources would be keeping up with yung mga researches. Yung mga AI companies usually nagpa-publish sila ng mga resources. Pero at the end of the day, it starts with siguro if syempre wala naman if you're still lost, Google and uh, Google and YouTube provide a lot of para introduction to NLPs, and then may mga roadmaps na rin doon. So may mga lectures. So yun.
Okay, cool. So, what do you think though, Ao? This, I think it was also help answer his question. What do you think of Andrew Nang's Coursera course on machine
Ayun,
learning?
yeah. Andrew Ng is, I think, one of parang isa sa mga most prominent na parang
Mhm.
nag-ano rin na, and not just in NLP but in machine learning. So his lectures actually in Coursera. And yun nga, may mga free certifications at in Coursera sometimes. Coursera,
Mhm.
datacamp.org. What's the other one? What's a Coursera? Kalimutan ko na eh.
Udacity.
Yeah, parang so may mga available na, I think LinkedIn, I think meron din.
Yeah, there is LinkedIn Learning.
Yeah, Google also have these parang certifications
Hmm.
online na free din siya. So regardless kung if you're a professional already or a student, I believe free naman din.
Mhm. So yeah, I guess that answers his question. Pero there's also there's someone else
Mhm.
who is asking a similar pero more narrowed down.
Mhm.
So are there any roadmaps that they can follow if they want to learn NLP?
Um, I think yeah, you have to get into the basics muna of NLP. Ganyan. Start with yung mga embeddings, yung basic models, things like that. And then uh, start on a task. Ano iba yung task na gusto mong i-solve? I think uh, then keep on reading researchers to keep on reading yung mga sa mga road yung again. So yung basic models, and then we go to contextual, and then transformer based. So deep learning to transformer based, RNNs, ganyan. And then transformers, birds, and then try try to kumbaga check on, let's say, a specific task. Gusto kong solve a specific task. So I think that's also another way that you could do it. So learn kung, ito pa yung, ano ba yung kailangan ko to learn this specific task. Okay, so ano ba yung problem na sinosolve ko, and then technically adjust your roadmap depending sa kung ano yung maging gusto mong achieve. So, yun. So, I guess my advice would be, start. So, yeah, you just start with the basics. So, master the basics, and then try. Then, doon ka na lang mag-progress. So,
Right. Okay, thanks, Al. Pero like one thing I noticed lang, like something I would infer from this question siguro is, do you need specific hardware to be able to learn machine learning, to learn NLP?
um, yung solid understanding of the mathematics, it's very crucial. Kasi machine learning is basically mathematics. Yung back end niya talaga, mathematical operations. So you have to be comfortable with mathematics, and then you have to be comfortable with programming, specifically Python. So usually Python yung marami yung ginagamit in machine learning or in NLP. You also have to be comfortable with research, and then Python. Yung sa tools, we have Google Colab and Anaconda, PyChart. So, mga open source naman yun. So, these are used yung para doon tayo nagko-code. VS Code iba din naman. Pero running, kung may GPU yung laptops nyo, mas maganda sana. Pero you can start naman using yung CPU lang ng laptops. Okay lang yan. So, pwede kang everyone starts. Pero if you have access to GPU, pero yun yan, Google Colab also has parang free GPU usage for a certain amount of time. So you can maximize those.
Okay, cool. Now, you have another question from Carlo Lasala. He's asking, since LLMs are quite popular right now? What is the most common like what's commonly used today in the industry, either research or business? Is it to build a model from scratch, or are we gonna utilize some transfer learning instead?
Um, Siyempre ano, actually depende yun eh. Yung mga big companies kasi, they really invest in building their own models. Uh, the OpenAIs, the Googles, and pero if you're a budding entrepreneur or a budding business lang or yung and you don't have these large computational resources, the best way ng approach talaga is transfer learning or yung fine tuning. Yun. So, kasi kumbaga fine tune or training or building a certain model or a specific architecture, it's another uh, parang a very, very big task na baka biglang, kumbaga, kumbaga very technical din siya. So if you're aiming to use LLMs in your, let's say your business or your everyday lives, ang usually way to go transfer learning or yun nga, yung fine tuning lang kasi una, it saves time, it saves resources. So yun, very ano na lang siya, parang plug and play na lang siya halos. So mas mabilis siyang i-integrate, mas mabilis mo magagamit into your certain use cases. So yun, transfer learning talaga.
Okay, all right, that cool, cool. Pero 'di ba, like speaking of transfer learning, 'di ba, there is one of the most popular open source LLMs right now is that of Meta's Llama, 'di
Yeah,
ba? Yeah.
Llama
So
3.
what do you think about Llama? Like, what are your comments?
I'm really, kumbaga, not just in Llama, but yung open source community, I'm really, kumbaga, happy that they're pushing yung limits ng open. Kumbaga, they're creating yung free, yung free models that anyone can use for research. Kasi not everyone has the capacity uh, financially to, pay for yung mga other models in say OpenAI, GPT, yung mga GPT models that everyone could pay. Kumbaga, they are provide these yung mga open source Llama and ganyan, Mistral, they are providing an alternative for these paid models. And also, kumbaga, since sumasabay na yung parang performance nila with the paid models, it parang it helps with yung parang advancement pa kasi hindi pwedeng makampante yung mga gumagawa ng paid models kasi meron silang competitor na almost same na yung performance. Okay, they they have to develop other or better other or better models pa in the future. So mas nag-advance pa yung technology na. So yun.
All right. Okay, thanks. Now, another question actually, they said, can you clarify how recall is measured based on a sample data? Can you give us examples of NLP research where Quezon City, I mean, quantum computing can be of advantage?
Okay. So yung sa recall based on sample data, let's say, balikan natin yung recall. Okay. Ito, recall. So recall is true positives and then true positives and saka false negatives. Okay? So basically what this is doing is, wait, kita ba yung screen ko? Kita naman ako.
Yeah, we
Yeah.
can see, we can see.
So basically ang ano niya is alin yung tama yung prediction, okay, na positive siya. So over yung true positives niya. And then yung mga syempre yung false negatives or yung mga dapat positive yung or positive dapat yung kanyang prediction pero ang sinabi ni ang prediction ni model is negative. So yun yan. So again, so we're yung sa taas true positive, so we're counting uh, how many did the model predict na true na yung ang tunay niyang label is true. over, again, yung true positives, how many did the model predict na true, which is, ang tamang sagot is true talaga. And plus, how many did the model predict na false na dapat true pala. So this is how we compute for recall. So examples of NLP research where quantum computing could be an advantage. That's a very very good. Pero in the long run kasi, I think I'm not really well versed with quantum computing. I'll be honest with that. Pero I think yung isa sa mga binopost ng ano is yung computing power din sa well, quantum computing, and I think it would boost actually not just one part of NLP. So I could see this being integrated in multiple application of NLP. Let's say starting from yung una, we'll be starting with the basics, yung mga basic na application. Pero in the end, pag through more research, maybe we could integrate it into, let's say, big architectures or more complex architectures in NLP. So this is something really exciting sa totoo lang. So I'm really looking forward dun sa lecture next week ni Sir Elmer. Oops, bigyan ko ng spoiler na kung sino yung represent next week. Pero doon kasi madidiscuss yung quantum NLP and how we would merge yung technology ng current NLP ngayon with quantum computing. So I think this would be better off, or bibigyan siya ng mas magandang clarification or sagot by next week or by the next lecture. Really excited for that one.
Right. So, thank you, Al, for that one. So far there are no additional questions naman. Pero sige, I think we can wait for a bit more. So, so just guys, just feel free to ask questions here. Al is here, is a wonderful answer. So, feel free. Huwag kang mahiya. So, while we're waiting for any additional questions, I'll just add something here now. How did you get started with NLP? Like, why did you become interested in it?
Mm, ako kasi parang mm, I have this parang passion of parang communications with people, communicating with people, so language, communication, things like that. And then nag-offer yung school namin during the pandemic na parang hindi patapos tail end na ng pandemic na nag-offer sila ng MSAI. So sabi ko, I I'll give that a try. So I fell in love with AI. And then hire ako sa DOST. So naging task ko doon would be more on NLP talaga. So doon ko sa dami ko pa na pwedeng gawin with NLP. And then yung parang passion ko with languages, with communication. So and then AI. So doon like spark with that. So uh, even right now yung sa mga sa yung sa mga researches ko, so more on language based na siya. So particularly yung code switching or the way we move from or parang move from one language to another na parang ganito seamlessly, uh, retaining the context. So this is kumbaga na-excite ako. And then yung parang sa preservation ng mga endangered languages. So those yung
Mm.
parang ganun yung mga parang advocacies na gusto kong iyan sa NLP. So yun yung parang konting background lang sa. So lahat ng research ko parang mostly dun yung research direction. So yun, parang you just
So you just found a spark that was like,
yeah.
ano ka na lang. Okay, that's interesting. You know, Kyle here also as an additional question. He'll just try asking it now. Will quantum
Mhm.
computing concepts help in the optimization process? What I mean by help is making it converge faster or maybe dig deeper to convergence.
Hmm. I think this would be better off with parang answered by next week.
Mm.
kay Sir Elmer. Kasi I don't want to give parang false hopes or false kasi baka mamaya mali pala yung sinasabi. Pero I think maybe ano, if I think that time permits naman, maybe we could have Sir Elmer.
Sir Elmer, are you
Yeah,
there?
yeah. Parang konting synthesis lang and then
Yeah.
baka ano, introduction maybe to
Mm.
ano,
Yeah. This would be a good transition to the
transition, yeah.
synthesis.
Yeah,
Yeah.
Sir Elmer.
Sir Elmer? Teka,
Ano,
i-message natin siya.
baka nagse-set up, baka nagse-set
Oo,
up or
baka
something.
rin nga.
Yeah, yeah. Yeah, I'm assuming so. Pero yeah, I think this would
Hello.
be a great, yeah. Hi, Sir
Ayun!
Elmer.
Hi, Sir Elmer. A bit, you're a bit choppy, Sir Elmer.
Sir, medyo ano po, may problema po ata sa connection.
Yeah,
Shopee. Yeah.
choppy. Oh, yeah, naging choppy. Yeah, so I think Sir Elmer is fixing his setup muna for the meantime, no? Yeah, yeah.
So yun, I think ano lang din yun, no? Lesson
Hello.
or parang
Oh,
letters. Yeah, Sir Elmer.
Sir Elmer. Say, try speaking. Sige, sir, try again. We actually got a small word out, pero baka may problem.
Mhm.
10-minute break. It's just place where
Ayun,
there is
there.
a
Okay.
Yeah, so I think we can do a very quick break.
Quick break, yeah,
Yeah,
before synthesis.
another 5 minute break for now,
Yeah.
while we're waiting for Sir Elmer to fix his setup. So, thank you so much for that wonderful lecture, no, and for
Yeah.
the Q&A session. So, sige, let's wait for Sir Elmer to get back. Mga let's make it 10 minutes siguro kasi to give him more time to fix his setup. Ay, all right. See you guys in a bit. All right, so welcome. Sorry to cut the break short, everyone, but Sir Elmer's setup has been fixed now. But if you're ready, let us know by typing G or 1 or 2 or 3 in the chat. Just to let us know if you're ready. Right, I see 1G. Okay. All right. Seems like a lot of people are going Gs right now. So, sige. I think we can head back to Sir Elmer. Sir Elmer, I think you can take the
oh,
stage right now.
good evening.
Yes, hi, Sir Elmer.
Okay, is my audio okay now? But I'm
Yeah,
gonna be
yeah.
using my video para kasi the thing is I'm currently traveling right now. So kanina when my name was called, it just so happened that I'm in the spot where there is very weak signal.
Mm,
So that's why I requested for a break muna because I'm currently traveling. I'm in a bus right now,
ah,
going back home. So that's the reason why. But yeah, good evening everyone. Thank you for attending this session. And I must say that Al did a fantastic job introducing us to the world of natural language processing, no? In the classical sense because parang kanina, no? Sean, just let me know kung nagka-cut off ako but
yeah, sure,
I'm
sure.
gonna be yeah, okay, sige, thank you. Thank you. Yeah, thanks everyone for tuning in and like what I said, I'm really glad that I was able to introduce us, no? Or give us a glimpse of what natural language processing is all about. So I'll be talking about the uh, quantum natural language processing next week. No, but because since we still have time, I just wanna parang do a synthesis of what Ao discussed a while ago. No, so first siguro let me start by defining what NLP is. No, basically, itong NLP, natural language processing. This is I consider it as a branch of or as a field of AI. No, this is basically an application of AI or artificial intelligence because it involves the interaction between computers and it- it's really a nice gift that we have. You know, very ambiguous. No, meaning computers natural language. No?
Yeah, Sir Elmer, I think you're back in a weak signal. You're getting choppy again. Sir Elmer,
So,
you were choppy kanina.
yung approach kasi,
Okay, yeah. So, Sir Elmer, yeah, we are getting choppy response again from you.
I just stop speaking because
Yeah, Sir Elmer.
okay. So,
Okay, a bit better.
uh, at what point where I cut off, once I cut off,
Yeah, you're choppy again, Sir Elmer.
was I cut off?
Yeah, you were a
I
bit
heard.
cut off kanina. Hello. Oh, okay. So, while Sir Elmer's out and we're still getting an update from him, Al, are you open for answering a few more questions?
Yeah, sure.
All right. So we have a few more questions here. So, another person asked tips for finding journals or papers related to machine learning or NLP.
Um, for machine learning, for NLP, I think ang usually sinasuggest namin, um, Google Scholar is a way to go. Um, ano pa ba? You just type in natural language processing or kung ano yung specific task na gusto mo. Let's say, machine translation or things like that. So you just key in yung keywords. So, tapos lagyan mo lang ng LLM or machine learning, things like that. So, ganun lang usually yung ginagawa. And then, check for kung alin yung usually yung maraming citations. Ano pa ba? We also, you could also go to, kasi in NLP, we have this parang yung ACL, so Association of Computational Linguistics. So, dun nakapublish ang mga parang papers related to NLP. So, you could check those out. So, again, that's ACL, Association of Computational Linguistics. And then, Google Scholar, then, yun nga, sa IEEE. So, nagpa-publish din doon. So, you just key and again, machine learning and then kaya natural language processing or yung specific task na gusto nyo. So, yun yung mga usually check if you want yung mga high quality to check for yung quality ng yan, check mo kung marami ba citations or uh, kung mataas ba yung maganda ba yung journal kung saan siya nakasubmit. Pero at the end of the day, it would still parang always be better kung babasahin niyo yung literature to check for its quality. Parang kasi hindi man at least may mapulot ka man something. So, yun.
Oh, right, cool, cool. Now there's another question here. May mga masasuggest po bang open data for NLP
Mm.
for a beginner?
Again, depende siya sa use case. Pero if there's always Kaggle, check natin. So that's kaggle.com. So depende na lang sa inyo kung ano, again, depende sa inyo kung ano yung use case ng gagamitin nyo. So type nyo lang yung use case or kung ano yung paggagamitan nyo. Kaggle, there's always uh, usually yung mga papers din, may mga papers kasi i-introduce ng mga bagong dataset. So usually free yun. And then, ano pa? Hugging Face also features yung mga datasets na pwede natin i-download for free. So that's huggingface.co. Huggingface.co. So yung sa Hugging Face naman, pwede rin kayo dyan mag-check ng mga models na pwede nyo gamitin for your specific use cases. So yun yung usually mga suggestions ko. So Kaggle, Hugging Face, so yun yung mga usually. Then GitHub kung meron man, yun yung mga, so, depends na rin sa use case niyo.
Okay, cool. Now, um, I remember DOST ASTI has released a paper on languages. I think it was by Sir Elmer and Ma'am Mitch. How would you may data set, open data pa siya, yung paper na release ng
Yeah.
DOST?
So our team released yung parang itanong dataset. So it's a benchmark dataset for downstream NLP tasks. So parts of speech tagging, sentiment analysis, things like that. So may mga models din. We plan to open yung parang open access siya earlier this year. However, parang mas to improve yung quality, parang mas substantial improve. So we're currently pa rin siya, hindi pa rin siya available publicly, pero we're hoping na in the near future is publicly maging available na yun. Mga, kasi siya nag-cater siya not just in pure Tagalog So it was in parang code switch, yung parang code switch data, and then there's also some Cebuano data, Cebuano text na pwedeng gamitin sa So yun, we'll be updating naman from time to time kung available na yung mga. Pero yeah, it was made with the intention of parang providing a data set for the Filipino people by the Filipino people. So,
Okay, so may follow-up question from Sam Matuba. Just want to ask for some leads. If anybody has experience on this, on which, wait, I think, on which NLP topics or techniques to explore and get started with for developing ontology for a particular domain. Say, all I have is regulatory documents and publications, and I want to map them all out into some form of knowledge representation.
yeah. I think yung you could if you want to map it out, I think you could also explore yung integration ng graph neural networks. Those that's one way. Another way would be maybe yung basic clustering lang. Then checking. And then yeah, yun yung mga initially on the top of my head. Pero yun nga, I'm no expert in this field. Pero if you are looking for a lead, I think integration ng graph neural networks, uh, relationships, maybe rin kahit yung basic na yung mga neural networks lang natin. So maybe it could. So,
Okay, cool, cool. So, right, I guess there are no more additional questions. So, Al, thank you, thank you once again for doing a last minute Q&A. Now, I think we can head back this one, the floor back to Sir. Wait, I think may nag-chat. Someone Sorry, someone chatted kasi, so I lost my composure. So yeah, I think we can give back, move back to the floor, give the floor back to Sir Elmer. Sir Elmer, are you there?
Yes, hello, good evening. Sorry about what happened a while ago. Shan, can you hear me?
Oh wait, yeah, we can hear you, sir. Yeah,
Okay,
we can hear
thank
you now.
you. Charla, let me just continue what I was saying a while ago. So I was defining NLP during that time. Basically, there are two branches of NLP. You have the natural language generation and natural language understanding. NLP is an application of artificial intelligence wherein you teach machines to understand human language, not only to understand, but also to generate text that is somehow that can be used for communication. So ako siguro I just would like to give a brief history, no? Kasi parang yung lecture ni Ao kanina is more of parang those are important things. No? I cannot overemphasize the importance of word vectors. Paka-importante nun. Just want to share with you yung experience ko as na nag-start ako kasi a lot of you are asking kung ano yung mga resources. Mamaya magbibigay ako kung ano yung mga resources. Although, Al has already mentioned some of them kanina. Oh, basically, NLP, may mga tasks kasi yan, no? In order for us to understand or even generate language, there are some tasks that are being explored in NLP. Siguro isa sa mga tasks na yun, just like in other applications of AI, like for example, in computer vision, di ba may mga tasks like image classification, object detection, object recognition, semantic segmentation, those are tasks under computer vision. In NLP, mas maraming tasks. Isa na classification, madami pa yan. You have topic modeling, you have authorship attribution, you have determining whether the gender of the author, for example. So that will fall, you have sentiment analysis, that's also text classification. Another thing, you have co-reference resolution, dependency parsing, named entity recognition, parts of speech tagging. So maraming mga tags sa NLP. Pero I would like to highlight two of them, no? Ay, isa pa yung question and answering o yung ginagawa namin yung sa itanong project, no? That's also a task under NLP. Also machine translation, yung sa Google Translate, no? Task din yun under NLP. Pero siguro yung isa sa pinaka-importante is yung language modeling. That's another task, language modeling. Yung gagawa ka ng language models, no? Remember those different tasks. Some of those tasks kasi siyempre, kailangan nyo doon ng mga evaluation metrics. No? Iba-iba yung evaluation metrics na ginagamit. Like sa language modeling, na-discuss na ito kanina, you have perplexity. May mga downstream tasks din doon na, na external yung, yung evaluation. Extrinsic pala, sorry, not external. Extrinsic evaluation technique. So yung perplexity, that's the intrinsic way of evaluating language models. But yung language model kasi, basically it's just predicting the next word or coming up with the probability distribution of the next word. Tapos mag-sample ka lang doon para to come up with the next word, tapos makakapag-generate ka na ng text. And doon sa mga tasks na yun kasi, no, there are some tasks there that you need to do in order for you to do the other task. Like, for example, in tokenization, that's a task in the NLP, but those things can also be used for other parang more larger tasks, no? To highlight those yung mga yun. Tapos yung dalawang approach kasi sa NLP na techniques o yung mga algorithms na ginagamit, you can classify them into two. Basically, yung iba na discuss na rin ni Al, statistical and neural network based. In the past, the way we do NLP is statistical. Ito nga yung frequency based. So yun yung mga statistical. But since 2012 siguro I would say, 2012 kasi yung parang birth ng deep learning, Pero 2013 yung word of egg. I also appreciate yung sinasabi niyo yung mga years na yun kasi they are. So what I'm to do here is I'm just giving a history of NLP, no? Yung before kasi statistical based lang yung ginagamit. Hindi siya ganoon ka-accurate. Pero nung advent ng deep learning, ang uso na yung AI, ayun, naging accurate na. Like for example, you would see Google Translate dati, SMT pa yung ginagamit niyan or statistical machine translation. Hindi siya ganun ka-accurate. Tapos nung nauso na nga itong mga transformers, yung naging neural network based na, mas naging accurate yung ni Google, yung machine translation ng Google, even yung Google search nung na-invento na yung BERT, na nabanggit ni Al kanina, naging mas accurate na. So gusto ko lang i-distinguish yun. Pag mag-aaral kayo ng natural language processing, in the past, before 2012, statistical techniques pa yung ginagamit. Pero after 2012, ito na yung neural network base. Ang nagpasimula nitong neural network base, nabanggit din ni Al kanina, si Joshua Bengio. Siya yung isa sa mga gumamit ng neural network sa natural language processing. I think that was back into 2012 na. Tapos na-invento yung word to vec in 2013. So yun yung word representations. So kung gusto nyo talagang aralin to, tama yung tinanong ni Al kanina. You would have to learn vector representation first, no? Yung word to vec. Pagkatapos noon, there is this paper in 2017, at the watershed moments ito, tong paper na to, yung attention is all you need. Kasi kung titignan niyo yung kwento kanina ni Al, no? Yung nagkaroon na ng, nag-start yung problem kasi with, tawag doon, sa machine translation, no? Usually, ang ginagamit nila, although neural network based na, ang ginagamit nila is RNN or recurrent neural network. Kaya lang may problem sa RNN, yung linear interaction distance, saka yung vanishing gradient problem, no, yung mga gradient problems na yan, yun yung naging problem niya. Pero hindi ko na i-detail dito siguro yon. I'm gonna have you learn that on your own by reading research papers. Pero yun yung shortcomings ng RNN. Pero basically kasi RNN yung ginagamit. Di ba sabi ko nga, una statistical based, tapos nag-neural network based na. Sa neural network, usually, sa NLP, ang ginagamit ay RNN. No? Before 2017, RNN. Tapos, may mga shortcomings na yung RNN because of the gradient problem. Merong isang variant ng RNN na gumagamit ng gating mechanisms, yun yung mga LSTMs. Pero RNN pa rin yun. Although nag-improve ng konti, hindi niya pa rin susolusyonan yung mga problems ng dependency, na parang long-term dependency. Halimbawa, meron kang subject, meron kang sentence na in France. France is the country. France is my. I grew up in France, no? I speak fluent blank. So ibig sabihin, no, para ma-answer mo yung blank na yon, you need to go back to the sentence para masabi mo let's say, French. Ganon. So,
Sir Elmer, sorry to interrupt, pero medyo naging choppy.
Interaction words or yung mga previous words.
Okay.
And okay naman yung RNN, suffer sila sa isang problem. So,
Sir, kanina naging choppy a bit kanina.
okay.
Now, yeah, okay na ngayon.
Yes. Yeah, okay. Yeah, it's okay. It's okay. Thank you. Yeah, the thing is, ang gusto ko lang emphasize dito is yung deep learning, yung using neural network, no? So nagkaroon ng RNN, pagkatapos may mga problem RNN, din nauso yung LSTM. Tapos may problem pa rin, hindi pa rin niya totally na-solve yung LSTM hanggang sa paper ng 2017 by Vaso paper na Attention is All You Need. Doon sinabi nila, yun yung title nila, Attention is All You Need. Ang ibig sabihin nun, sinasabi lang nila na, oh, hindi nyo na kailangan ng recurrence. All you need is attention. So doon, before that kasi na-introduce na yung attention mechanism sa kayong alignment. So nag-start talaga to sa machine translation, yung pagta-translate from one language to another. Doon yung try, gusto nilang isolve. Hindi na solve ng RNN, pero nakapag-provide yung attention mechanism ng better way of doing the machine translation problems.
Oh.
Generally, the language modeling problem. And then yun nga, karoon ng paper yung attention is only introduced yung concept ng transformer. But even before that, yung mga neural networks kasi they are parang architectured in such a way na meron pang encoder at saka decoder. Yung encoder, so ito yung nag-encode ng input mo. Yung decoder, basically ito yung nag-generate ng text based doon sa panibago. Let's say for example, if you're doing a translation, you need to encode the the words in a in an encoding wherein meron kang parang kino-compress mo yung essence ng input mo, and then ipapasa mo yung compressed input na yun into your decoder, wherein yung decoder naman somehow may knowledge siya nung language na pag-aanohan, tapos based on the input or condition on the context, magge-generate siya ng text. So basically, that's how machine translation works, no? Marami ka ng encoder and decoder. And that's why nung sa paper ng ng Attention is All You Need ng 2017, meron siyang yung transformer architecture, it is composed of an encoder and a decoder. Ngayon, yung encoder, nabanggit niya, no? Pwede siyang gamitin as a language model or sa parang pag-generate ng contextual embedding. At yun nga, yung unang contextual embedding kasi ang ginagamit is bidirectional LSTM, yun nga yung ELMO. Pero nung nauso na yung transformer, ginamit nila yung encoder part ng transformer, doon naman nauso yung BERT. Mas naging powerful si BERT kaysa kay Elmo. Kasi si BERT, siya yung kalahati nung sa transformer architecture doon sa attention is all you need. So yun, basta importante dito yung attention mechanism and then yung multi-head attention transformer. Yun din yung isa pang innovator na yun from yung sa pa yung positional encoding. Basically, sinasabi doon sa neural network na yun, na transformer architecture, wala ka ng recurrence neural network na kailangan. Although there is still nonlinearity, to introduce nonlinearity, you would still need multi-layer perceptron o yung feed-forward neural network. Transformer architecture yun, it has two parts, the encoder and the decoder. Yung BERT, that's the encoder part. Okay? Doon yun. Ngayon, I'm sure you're already familiar with GPT, di ba? O yung sa ChatGPT. GPT stands for Generative Pre-trained Transformers. Okay, dun sa decoder na part naman yung tinuha. So decoder na part, yung kalahati ng architecture na yun, doon sa paper na yun, kung titingnan ninyo, doon naman sinuha ng mga GPT or Generative Pre-trained Transformers. Ito naman yung mga language models talaga na nag-generate ng text. May GPT-1, GPT-2, GPT-3, and then in 2021, nagkaroon ng GPT 3.5 or touted as ChatGPT. So, pinrain nila yung GPT 3.5 GPT. So, basically yun, kung ituturo ko sa inyo yung architecture ng transformer, it involves a lot of computation, a lot of matrix multiplication. And that is why it's important for us to explore other alternative ways of computing. Doon ko naman i-introduce yung quantum computing. So basically, in quantum computing naman, it's just the application of quantum natural language processing is just the application of quantum computing sa natural language processing. As you can see kasi language is very intricate, it's very complex. It's really hard to comprehend. So that is why it's an alternative approach to doing NLP, no? Ibig sabihin, we're gonna use yung mga phenomenon sa quantum computing like superposition, entanglement, and interference to do yung mga computation sa NLP. As you can see, di pa, yung context, halimbawa na lang, yung contextual embedding na inano ni Al. Pwede kasi magamit yun yung superposition. And then other, like for example, yung semantics and syntax ng isang, language structure, pwede mong gamitin din yung concept ng entanglement. I'm gonna expound more on this Saturday. But basically, and I want to say that neural network, NLP, basically, ang approach ngayon is using deep learning or yung mga neural networks, no, and transformers. And they involve a lot of mathematics, as Al mentioned a while ago. And that is why I also fell in love with this field because I love math. I also love math. Ngayon, with regards to resources, meron isang book na lagi kong nare-recommend, yung kay Speech Processing and Natural Language Processing, I think by Christopher Manning. Okay din yung kay Jurafsky na ito yung mga I'm gonna share them with you. Pero doon, ito yung one of the best books na also yung Stanford na course na CS224N. Ibig sabihin, that's Natural Language Processing with Deep Learning. Meron na sa YouTube. CS224N. Medyo nga lang, brace yourself kasi medyo technical yon kasi Stanford level siya. Pero sundan nyo lang yon tapos yung book na sinabi ko sa inyo. And then, what else? Ayun, sige. I don't want to preempt my lecture on Saturday. Pero kudos to Al for putting up a good presentation about the introduction to natural language processing, no? At saka siguro to answer na rin yung isang question dun sa ontology. Perhaps if you have those policies, or you have text, if you somehow fine-tune a large language models on those data sets, you can probably come up with a large language models on those training data sets. That's all. Thank you. I'm happy to answer some of your questions if you.
Thank you, Sir Elmer, for the synthesis. So if you have few more, we have, I think we can take at least one more question. Is anyone going to ask for Sir Elmer? I think the question for kanina, I think it was also answered na. Yeah, Kyle's answer. Siguro. Siguro, Sir Elmer, I think we can ask Kyle's question kanina. Will quantum computing concepts help in the optimization process? What I mean by help is making it converge faster or maybe dig deeper to convergence.
Yeah, the answer is yes. The answer is yes. Kasi maraming way you can do it. With quantum computing kasi, like if you have basically in quantum computing, pwede ka mag-parallelize ng sabay-sabay. And one of the advantages of transformer-based neural networks paired with RNNs. Sa RNN kasi may mga merong bottleneck dahil you work with sequentially, no? Yung hidden states, kailangan mo na ma-process yung isang time step bago ka makapag-proceed sa next time step. Whereas yung transformer, using multi-head attention, pwede mong i-parallelize yung sabay-sabay mo mako-compute yung interaction to alignment ng bawat word sa isa't isa. Wala siyang linear na or sequential na parang you can parallelize. Now, parang thinking sa quantum, that's one of the way. Sa quantum kasi since you can represent several, kunyari, you can represent several words with different state at the same time. So doon ko nakikita yung is one of the application of quantum, yung paggamit ng superposition. Kasi nare-represent niya yung iba't ibang, let's say, dimensions ng word or at the same time doon sa sentence. So that's one thing, But basically, yun din naman yung yung parang advantage ng quantum computing. You leverage on superposition, entanglement, and interference. So tingnan mo na lang how will that facilitate the computing. Kasi ang computation ng very complex na sa language sa NLP. Very complex, kaya kung titingnan nyo yung transformer architecture, that's very intricate at saka ang daming computation. But the thing is, ang matagal pa rin. Baka marami pa rin may mga approaches sa quantum na mapapabilis yun. I hope that answers your question.
All right. So yes, Kyle's just said thank you, Sir Elmer. So I think we can no longer accommodate more questions. So Sir Elmer, thank you for the great synthesis on Al's lecture kanina. So just before we end, I'm just gonna do our standard temperature check. So from a scale of 1 to 9, how was the session? So if you're still fine at 1, or if you're drowning, or if you're cooked, say 9. It's 6, 8, right? Ooh, okay, that's a lot of 7, 8, and 9s actually. All right, so before we end, everyone, let's do a quick photo op. So yeah, I love everyone to open their screens, and let's do a quick photo op. Okay. So for everyone's for the attendance, this is the attendance code, and this is where you can sign up. This is the form for your attendance. And once again, everyone, thank you for joining us in the seventh session for the QNLP series.